yourselves. I'm Kanyisani Falaki from Abbott's College. I'll be giving you a quick crash course on what you can do to get yourself out of a tight corner if you're finding yourself in one, just to make sure that you get that pass at the end of the year. So we'll be going through Math Paper 1, just looking at a few things that you can do to make sure that you get all those marks. First thing you need to be familiar with are the topics in paper 1. So we have equations and inequalities, that's the first topic, number patterns and sequences, functions and graphs, financial math, calculus, and probability. So if you're finding yourself in a tight corner at this point, it's probably best if you focus on a few subjects that are doable and manageable and studyable and give them your 100% so you can get that pass. So these topics or main topics that we're going to focus on are equations and inequalities, number patterns, and calculus. These are easy sections, but they're worth a lot of marks and you can actually get past that 50% mark if you give it your 100%. So you also need to know your exam guidelines. So for algebra, you need to know when you're solving quadratic equations, what do they look like, what to use, what is actually being tested. Because these exam guidelines tell you what the examiners are looking for, and they'll guide you in terms of structure, how you should structure your questions. So when we're looking at algebra, you need to be able to complete the square, yes, but in this section, it's not tested. You actually tested for completing the square in analytical geometry, which is in paper 2. So don't worry too much about completing the square. When you're solving your quadratic equations, you need to be able to use the K method. So if you see something that looks a bit complicated, always think, how can I make this simpler? Use the K method. If you don't recognize something, change it into something that looks recognizable for you. The third point, if you have surds, those are definitely going to be examined. Know how to deal with your surds. Nature of roots will be in there. When we're talking about number patterns, sequences, and series, you need to know the differences between your first difference, your linear patterns, your quadratic patterns, and your geometric patterns. So you need to be familiar with these exam guidelines because they'll tell you or they'll let you know as you're studying what is not being tested and what is expected of you. Moving on from there, differential calculus. This is one of the best and one of my favorite sections in math, but you need to know what is expected of you. Familiarize yourself with the notation that is being used. So if you see this f prime x or dx or dy dx or y prime, you need to know what the instruction is. Don't be shocked because it looks a bit different to what you used to seeing in class. Be comfortable with your cubic functions. Those will be tested. So be able to know what they want from you, how to get as many points or collect as many marks from a particular section as possible, just by using these guidelines. What is being tested? What are the important parts? You should be able to draw and interpret your graph. This is the exact same expectation that we have for the function section, which I won't be going through, but this is the exact same thing. Surface area and volume, you should be able to work with those formulas. You're not expected to know the formulas. You will be given the formulas, but know when to use what. Look for keywords. When you see volume, when you see surface area, you know that area is going to be squared. Volume, you're looking at something that is cubed, and be able to use that in point number 6 when you're asked to work with optimization questions. Right, the most important part, your information sheet, your formula sheet. You need to know what each section is for and maybe cross it out when you're done with it. So sometimes people get overwhelmed when they see the formula sheet in the exam. You don't know where to look exactly. And actually, it's so easy. Everything is laid out for you. All the things you need for question 1 are in the first row. The quadratic equation is there. That's what you use for the first question, which is equations. Question 2, when you get to financial mathematics, you have your grade 11 finance formulas. Once you get to sequences and series, you have that section of formulas. These are grade 12 sequences and series, which are your metric sequences and series. That's for your grade 12 finance. Your calculus is there, and then you have your analytical geometry. So know what is where on your formula sheet, so that when you're busy with a certain question, you know exactly where to look and you don't waste too much time trying to find things on your formula sheet. Right, so I'm going to go through a couple of questions. Just give you a few tips on how to recognize what each question wants from you and how to deal with each question. So if you look at this question in front of us, solve for x by factorizing. They look very similar. You have question A, B, and C. These look very similar, but they actually require a different set of skills from you. The first one is a quadratic trinomial. And generally, to solve a quadratic trinomial, take everything to one side of the equation, equate it to 0, open up your two brackets if you're comfortable with that. If you're not comfortable factorizing a quadratic trinomial, use a quadratic formula that's on your formula sheet. And then with this type of question, of course, because it's quadratics, we have an x squared term, you're always going to get an answer that is either two values or two values that are exactly the same or two values that are different. So here you can see that we have two values for x is equal to 1, x is equal to 4. That's a quadratic trinomial that you solve through factorization, opening up your two brackets or using a quadratic formula. The second question, B, looks very similar to A, but it's fundamentally different. We don't have the third term. We don't have that constant term, the 4, that you have to take over to the other side of the equation. So in this case, you have to take out a common factor. So you look at the two terms that you have and ask yourself, what is common to both terms? X is common. Take out the common factor and then use your null factor law to then further solve the equation. If you use your null factor law, it will tell you x is equal to 0 or x is equal to 3. So be careful of equations like this, because what most people tend to do when they see two terms is want to divide by the variable, and you never divide by a variable. So keep that in mind. Rather take out a highest common factor instead of dividing by a variable, because you'll lose out on one of your solutions. And then my favorite, again, in this case, we have the x squared term. We don't have the negative 3x or the middle term, and we have our constant term, which is 4. So this is a classic difference of two squares. You can either take the square root of both sides, or you can factorize it using a difference of two squares, take everything to one side of the term or one side of the equation, and then have your two brackets, which will consist of the square roots of the first term and the second term. Square root of x squared is x, square root of 4 is 2. So that's the first part. And you're always going to get this question in your exam. The first question is always going to be quadratic equations. Up to you how you want to solve that. It's either you use your quadratic formula. If you see that you have two terms, use your null factor law, take out a highest common factor. And if you see a squared number or two squared terms, use a difference of two squares. And then secondly, here we also have a quadratic equation, but this time around, it's not factorizable by just opening up your two brackets. You can't use the null factor law, and you cannot use a difference of two squares because you do not have a difference of two squares. If you look at A, which is 2x squared minus 3x equals to 4. So you do what you do. When you have a quadratic trinomial, take everything to one side of the equation and use a quadratic formula. The quadratic formula is given to you on your formula sheet. It's the first formula there. Use it. You need to know what to substitute where. So if this is your quadratic trinomial, you're looking at the coefficients of the x terms. So it's 2x squared minus 3x minus 4. The coefficient of the x squared term, that's your a, which will then substitute into this quadratic formula. The negative 3x is the coefficient of your middle term, which you then substitute in place of b. And then c for constant, your constant term is the negative 4, which you'll then substitute into your quadratic formula. It's very important to show your substitution. So when you're doing substitution, when you're substituting in values, show it by using brackets, because that's a mark. Instead of doing everything on your calculator and you're writing down the final answer, show your substitution, because that's where you're getting your marks. And the aim is to collect as many marks as possible. Let's look at B. It's 2x squared equals to 4. This looks like a difference of two squares, but it's not. Because this 2x squared term, the x squared is a squared term, but the 2 is not a squared number. So you have to treat it as if it was a quadratic trinomial. But in this case, b would be 0. So when you substitute this into your quadratic formula, your a is the coefficient of the first x squared term, which is 2. Your b is the coefficient of the middle term. In this case, we don't have a middle term. We don't have an x term, so that b is 0. And then c for constant, your constant term is -4 based on how you've arranged it. And then substitute that into your quadratic formula and write down your answers. Please, I want to emphasize this. Show your substitution. That's where you get your marks. Rather spend your time doing things thoroughly, showing all your steps so that you can get as many marks as possible. Okay, and then the second part, once you have your quadratic equations, there are going to be inequalities. An inequality, even though when you solve it, you treat it as an equation, this last part over here where you have to show your sketch is where the difference comes in and how you interpret your critical values. So if you don't know what to do, this is my motto. If you don't know what to do, do what you know. If you're writing this exam, you see a question such as x squared minus 3x less than 4, and you feel confused because that inequality looks a bit different to the equals to sign that you're used to. Do what you know. Treat it as you would treat a normal quadratic equation. Take the 4 over to the one side of the equation, move everything to one side of the equation, make sure that it is equal to 0, treat it like an equation, open up your two brackets and factorize. If you're not comfortable with that, remember, you have your quadratic formula, use that. Use the quadratic formula or your factorization to solve for your critical points. These critical values, these are what are going to help you interpret your sketch. You can either use the number line if you're comfortable with that, or you could use your parabolic sketch if you're comfortable with that. And with these types of questions, it's important to say it out to yourself in English. What is the question saying? It's asking you, where is the function x squared minus 3x minus 4 less than 0? So that symbol is less than 0. It opens up towards the 0, which means that the 0 is the bigger part of the equation. So it means that this whole function, this whole expression is negative. It's less than 0. So if you choose to use the parabolic solution for your sketch, you then have to plot your critical points. You do get a mark for your sketch. So please, even if you're not sure what you're doing, have a number line, plot your critical value so that at least if there's a mark to get, you get that. Plot your critical values. You have x is equal to 1 as your first critical value, x is equal to 4 as your second critical value. Plot them on your number line, plot them on that sketch of a parabola. It doesn't have to be a perfect sketch. This is just for you to interpret your solution. So if you look at this sketch over here, we have our parabola. It cuts the x-axis at -1 and at 4. Go back to what the question is asking you. Where is the function less than 0? So where is the function below this x-axis over here? So your answer or your solution is this part, the bottom part of your graph, because that's where the graph is below the x-axis. And as you can see, this part is combined in a way. It's part of the graph. And it's not two separate entities or two separate sections of the graph. It's one section. You're starting at -1 and you're going all the way to +4. So that whole thing is your solution. And when you represent it, you write it like this. And it makes sense if you say it out loud. X is in between -1 and +4. And you write it like that. You put x in between -1 and +4. One other thing to remember is, if the inequality doesn't have an equals to sign at the bottom, your answer should also not have an equals to sign. Use the inequality, the same inequality from the question, use that in your answer. So the inequality doesn't have an equals to sign at the bottom, your answer will not have an equals to sign. If your solution is between two values, your x also has to be between two values. And you can choose to write it in any of these forms. You can either use that form if you're comfortable with it. You can use this form if you're comfortable with it. Whatever you want, choose that and stick to it. Master it, stick to it, and be comfortable to use it whenever you see an inequality. And then the third type of question that is going to be asked in your algebra section, equations that deal with surds. Now, a surd is the symbol here that looks like Table Mountain. It really does. When you see that, remember two things. Treat it as if it is a variable. That's the first thing. Treat your surd, everything that is inside that surd or underneath that surd, as if it's one thing, as if it's a variable on its own. That's the first thing you need to remember. And when there's a surd, you need to get rid of that surd, and you get rid of surds by squaring it. Square both sides of your equation. If everything is on one side of the equation, isolate your surd. Make sure that the surd, this term that has this Table Mountain form, is on its own. Make sure that it's on its own on one side of the equation. Isolate it. Move everything else that is not inside the surd on the other side of the equation, to the left or to the right, depending on what you're comfortable with. And then the second step is square both sides. Once you've isolated your surd, make sure you square both sides of the equation and solve it as you would a quadratic equation. Once you've squared both sides of your equation, you can either be left with a linear equation. Yes, celebrate. If you have a linear equation, great. Easy. If you have a quadratic equation, still easy. Remember, you can either use your quadratic formula, first formula on your formula sheet, or if you're comfortable, open up your two brackets and factorize the trinomial. Right. And the most important part, when you have a surd, this is always the case. Check your solutions. You're going to either get one solution or two solutions, depending on whether you're left with a linear equation that you have to solve at the end or a quadratic equation that you have to solve at the end. Whatever you have, check your solutions. So once you have your solution, so here we took our surd to one side of the equation, we isolated it, squared both sides, solve the linear equation, take the 3 over, it becomes 6, 9 minus 3 is 6. So you have that one solution. You might think, no, you don't have to check, but you always have to check your solutions. So take that solution that you find, that value for x, substitute it back into the original expression, and check that the left-hand side is indeed equal to the right-hand side. You'd be surprised how many times that is actually not the case. Check your solutions, check your solutions. Even if you bugger up this whole calculation, even if you do something that is not correct, you could get a mark for actually doing the last thing correct, checking your solution. If you make mistakes somewhere in your calculations, but that last step, checking your solutions, you could get some marks. So do everything that you can to get as many marks as possible. If you see that Table Mountain symbol, if you see that surd, remember, check your solutions. If you look at B in this case, it's a bit different to what we have in this first example A, because now in A, our surd was already isolated. Okay, we had square root of x plus 3 on its own on the left-hand side of the equation. We had this 3 on its own on the right-hand side of the equation. So half the work was already done. If you look at B, it's a bit different. It's not more difficult, it's just a bit different. It requires more steps, but the procedure is still the same. You want the surd on its own. You want that x minus x plus 3, square root of x plus 3, isolated on its own on one side of the equation. So take the x over to one side, take it over to the right-hand side. So then you have two parts of your equation. One part has the surd, one part doesn't have the surd. Follow the steps, square both sides of the equation, solve your equation either using your factorized brackets or your quadratic equation. And then once you have your answers, check your solutions. Check your solutions. So look at the first solution. We had x is either equal to 1 or x is equal to 6. Once you have those and you check your solutions, you find that actually when you substitute the 1 back into the equation, the left-hand side of the equation is not equal to the right-hand side of the equation. And when you have something like that occurring, make sure that you let the examiner know that you know that that solution is incorrect. So you go back to these values that you found for x and show by drawing a line through an equals to sign. That's a not equals to sign. Or say this is not a solution, but state very clearly that you know that one of those is not a valid solution. So that's for surds. And the third type of question, I'm going to go through this one very quickly. It's nature of roots. There's usually one question that's testing your knowledge of nature of roots. This is a lovely section. I love it because instead of using the whole quadratic formula, you're only using this little bit, this discriminant. We call it the discriminant or delta. So you just use delta, substitute your values for A, B, and C from whatever quadratic equation you have, and then to analyze your nature of roots or to be able to comment on what type of roots you have. This part is where we actually want you to just comment on what type of x value you have. If you solved your quadratic equation using calculation, what type of x value is it? Is it an irrational number? Is it a natural number? That's what we mean when we say nature of roots. What type of number is it? And you don't have to actually solve the whole equation. You just have to use the discriminant and be familiar with these descriptions. What happens if the discriminant is greater than or equals to 0? Your roots are going to be real. If the discriminant is less than 0, you're going to have imaginary roots. If your discriminant is equal to a perfect square, you're going to have a rational root. If your discriminant is not a perfect square, you're going to have an irrational root. That's all you need to know. Familiarize yourself with this table and you'll be able to work through a nature of roots question. And then secondly, the first part was algebra, your equations. Second part, number patterns, sequences, and series. These sections are my favorite sections. They're really easy to get through if you master them. You need to know, firstly, your definitions. When you see your formula sheet, because you always have to go back to your formula sheet, when you see a question that's testing you about sequences and series, firstly, know which part of the formula sheet to look at. And then once you've looked at your formula sheet, know what each term means. What does each variable mean in that formula? So N is the term position. Position can never be negative. So N is the term position. It has to always be a positive number and it cannot be a decimal. I cannot be in the 1.5th position. It has to be a whole number, so it's either in the first position, second position, etc. It cannot be a negative number, it cannot be a decimal. Then we have S of n, S for sum. When you see a formula that has S of n or that wonderful Greek letter sigma, that's where we're talking about summation. We're adding up the terms. Tn, T for terms, that's when you just have your sequence. We use the SN for series. We use TN for sequences. And then this lovely symbol here is your sigma, which is just a fancy way of writing S, sum. You're adding the terms. Again, I want to emphasize, love your formula sheets. Get to know your information sheet to know where each formula is. So the second part is of the formula sheet. That's where you look for the formulas for your number patterns, sequences, and series. The first part is for arithmetic sequences and series. Second part, geometric sequences and series. Okay? And know what to use, when to use it. If you don't know what to do, do what you know. You're given a series or a sequence, the first thing that you do is find the differences between the terms. If you don't know what to do, do what you know. Find the differences between the terms. If there's a constant first difference, it is an arithmetic sequence or a linear sequence. You will have this equation. It's in your formula sheet. So A is the first term. Substitute 1, which is A, your first term. Substitute D, which is your constant first difference, into the equation that you will have on your formula sheet. And then use what you know to get what you want. The questions will lead you, right? The constant difference is D, substitute that into the formula. And to find D, it's term 2 minus term 1. First term, A. Remember that. And then this is a quadratic sequence. It's a bit different to the linear sequence because here we're looking for constant second difference. As soon as you see a pattern, as soon as you see a sequence, find the differences between the terms. Term 1 minus term 2. If that difference is not constant in the first line, then continue. See if there's a constant second difference. If that's the case, you have a quadratic sequence. So you work from the bottom up and you look at the first term of each row. So the last row, you have 2a equals to the first term of your second differences. The second row, the middle row, you have 3a plus b equals to the first number in that first row of your first differences. And then that first value of your sequence is going to be a plus b plus c. This will always be the case. You work from the bottom up. The key is to recognize whether you have a linear sequence or a quadratic sequence by finding the differences between the terms. And then you have your geometric sequence. This one is different from the first two because now you have a constant, a common ratio. Divide the terms by each other. They'll give you a common ratio, which is R, which you can just substitute into that equation. Again, it's on your formula sheet. So all you need is A, which is the first term of your sequence. Then you need to find R, which you get by dividing the terms. And once you have that, substitute it into the general equation that you'll have on your formula sheet and read through the question and they'll guide you. You know what is needed. You already have everything you need. You just need to trust yourself. Use what you have to get what you need, right? And then the second part is series. Series, similar to sequences, it's just that now you have pluses. It's the same thing. You have the formulas. All you need to do is know what to substitute, where to substitute it, when to substitute. If there's a constant first difference between the terms, it's arithmetic or linear. So you know what to use, go to your formula sheet and use that. If you have a constant ratio between the terms, such as this example over here, then use your geometric sequences or use a geometric series. Same with the sum to infinity. All you need is to find A, easy to find, that's the first term, it's 2. Find your R, your ratio, easy to find. Take the second term, divided by the first term. Substitute those values into the formula that you should already have from the formula sheet. And then everything else will make sense from there. But remember, if you don't know what to do what you know. Look at what you have. Use your formula sheet. Tear it from your exam script and have it next to you. Find the definitions. Look at the definitions. Be familiar with them. What is A? A is the first term. What is R? R is the constant ratio. How do you find it? And then once you have those basics, everything else will become very, very easy. Okay, and those are some examples. Again, if you don't know what to do what you know. Sigma notation, it's exactly the same thing as you would do with normal series. A normal series or a normal sequence, the only thing is now we have that symbol. All you need to remember is expand it. Expand it, write out the formula. This is just a shortcut to describe something that you already know. So if you're given that this is your sequence, use your sequence formulas to find your A and your D, your constant first difference. Substitute those values, find your general term formula, and then all you need to do is take that general term formula and then write it next to the sigma. That's all it's about. You're doing the exact same thing. It's just that now using shorthand notation. And then at the bottom of your sigma, you have where do you start substituting values? What is your first term? Is it term number 1 or is it term number 4 when you're adding up these terms? You start adding from term number 1. Where do you stop adding? That's what you put on top of the sigma. You stop adding at 20. And if you ever ask to find out what is the total number of terms, and you're given sigma, this notation, instead of an expanded sequence, remember the top number on your sigma, the top number, subtract the bottom number on your sigma notation, plus 1 will give you the total number of terms if you need that in a calculation. And then again, substitute integer values into either your k or your n to expand your sigma, and then do what you know. Use either your linear sequences, arithmetic sequences, geometric sequences, or quadratic sequences to then complete whatever it is that you asked to complete. And then lastly, and I won't go through this in detail, but calculus, it's a very easy section. All you need to know is the rules. Okay, this is a 10-mark section. Make sure you get these 10 marks. And it's simple. Remember this. Take the exponent, bring it down, subtract 1 from the exponent. So if you have your expression or your equation and you're asked to differentiate it by rules, easy. Bring down the exponent. This is x cubed plus 2x minus 3x plus 4. Bring down the exponent, subtract 1 from the exponent. That you look at each term separately. That is all it is. Bring down the exponent. I've brought down my exponent 3. It's now a coefficient. Then subtract 1 from that original exponent. 3 minus 1 is 2. So once you've differentiated x cubed, it becomes 3x squared. And then the same here, you have 2x squared, bring down the exponent, subtract 1 from the exponent. This is something you should be very, very familiar with. It's so easy, just follow that rule, but sometimes you need to do some simplification before you can get to using that rule. But if you remember, bring down the exponent, subtract 1 from the exponent, it's very easy. It's an easy 10 marks to get in your bag. And most times, this section also goes with your exponential laws. Go through your exponential laws, be comfortable with them, and use them in this section. And that is it. And that's everything for paper 1 to make sure that you get as many marks as possible. These are the easy sections, and I want you to get all of those marks. Thank you.
It's true. The thing about creativity is that sometimes like you're too direct with it. You almost kind of clamp up. And that kind of when you step away and you give yourself some perspective, you're definitely able to give yourself more room to kind of let it flow. Having a career in filmmaking is very difficult for any person. It's particularly difficult for women and particularly difficult for women of color. My message would be for people to know that you don't have to get it all right now. It's okay if your life isn't perfect right now and you're struggling now and you're having to take other jobs to make it work. We're playing a very long game, and a healthy career takes time to build. You don't have to peak in your 20s. And if you only make your best work in your 40s and 50s, you still will have made your best work. Things that seemed like they were mistakes at the time or detours at the time really were just part of the journey and helped me better understand what I do now.